Welcome to Nimu's World. It's me Nimesh Naik. Today I am discussing CSIR net questions June 2019. Topic linear algebra. It's a part C question. Question: consider a matrix A is equal to Aij is of order 5 by 5 where 1 less than or equal to I comma j which is less than or equal to 5 such that Aij is equal to 1 by ni plus nj plus 1 where ni comma nj belongs to n. Then which of the following cases A is a positive definite matrix? Option number 1, ni is equal to I for all I goes to 1 to up to 5, and second option n1 less than n2 less than etc up to less than n5, and option number 3, n1 is equal to n2 is equal to etc equal to n5, and option number 4, n1 greater than n2 greater than etc greater than n5. So this question is solved by using the concept of Cauchy matrix. So first of all we want to know what is Cauchy matrix. So definition: Cauchy matrix, let A is equal to Aij is of order m by n where 1 less than or equal to I less than or equal to m and 1 less than or equal to j less than or equal to n such that Aij is equal to 1 by xi plus yj where xi and yj belongs to a field f and xi plus yj which is not is equal to 0. So a matrix of this form is called a Cauchy matrix. And we want to know that what is Cauchy symmetric matrix. A Cauchy matrix is said to be Cauchy symmetric if xi is equal to yi. Next we want a result. A Cauchy symmetric matrix is said to be positive definite if and only if all xi's are positive and are distinct. Now we are going through the option. Our first option which says that ni is equal to 1 for all I goes to 1 to etc up to 5. So our given matrix is of order 5. So we are constructing we are taking a general form of a 5 by 5 matrix, that is A is equal to the matrix A11, A12, A13 etc up to A15, and A21, A22, A23 etc up to A25, and the last row A51, A52 etc up to A55. So from the question it is given that Aij is equal to 1 by ni plus nj plus 1. So here we from our first option we are assuming that ni is equal to 1 ni is equal to I, that is n1 is equal to 1 and n2 is equal to 2 and n3 is equal to 3, n4 is equal to 4, n5 is equal to 5. So we want to construct our given matrix. So we have given that Aij is equal to 1 by ni plus nj plus 1. So for the first element a11th term it's become a11 is equal to 1 by n1 plus 1. So n1 is equal to 1, so it can be by n1 plus 1, so 1 by 3. Similarly a12 which is equal to 1 by n1 plus n2 plus 1, so 1 plus 2 plus 1 which is equal to 1 by 4. Similarly we can get the rest of these elements. So we get 1 by 5, 1 by 6, 1 by 7, and for the second row here we have a21, so 1 by n2 plus n1 plus 1, so which is equal to 2 plus 1 plus 1, so 1 by 4. Then next element 1 by 5 etc up to 1 by 8. Then the last row of this matrix is 1 by 7, 1 by 8 etc up to 1 by 11. So by this matrix it is clear that it is a Cauchy matrix, and also we can see that it is a symmetric. So we can say that it is a Cauchy symmetric matrix, and we have a result for a Cauchy symmetric matrix is positive definite if and only if all the xi's are positive and distinct. From observing that we can see that all the xi's are positive and are distinct. So therefore we can conclude that A is a Cauchy symmetric matrix and all the entries are positive and distinct. Therefore we can say that A is positive definite, or otherwise we can look the all the leading principal minors of this matrix are positive. Therefore in that way we can also conclude that A is positive definite. So our first option is a correct option. Now for the second option which says that n1 less than n2 less than etc less than n5. So I just taking n1 is equal to 1 and n2 is equal to 2 and n3 is equal to 3 etc. up to n5 is equal to 5, and we have 1 less than, 2 less than, etc. up to less than 5, and we have A is a 5 by 5 matrix with Aij is equal to 1 by ni plus nj plus 1. So by using that we can compute this matrix is like this. So we get A is equal to 1 by 3, 1 by 4 etc. up to 1 by 7, 1 by 4, 1 by 5 etc. up to 1 by 8, and the last row 1 by 7, 1 by 8 etc. up to 1 by 11. So it is also again a Cauchy matrix, and it is also a Cauchy symmetry matrix, and all the entries are distinct and are positive. Therefore we can conclude that A is positive definite, or otherwise we can look the leading principal minus, all are positive. Therefore we can conclude that A is positive definite. So for our second option is also correct. Now we are going through the third option. Our third option is says that n1 is equal to n2 is equal to etc. to n5. So we are taking n1 is equal to n2 is equal to etc. to n5, which is equal to n, which is equal to 1. I taking n is equal to 1. We can choose any value. So for n is equal to 1, we can construct our matrix A is equal to 1 by 3, 1 by 3 etc. to 1 by 3, 1 by 3, 1 by 3, 1 by 3 etc. 1 by 3, 1 by 3, 1 by 3. Since Aij is equal to 1 by ni plus nj plus 1, so we can taking ni, all the ni's are I goes to 1 to etc. up to 5. We are taking which is the value is 1. So we get this matrix, and this matrix have the rank 1. So it is not a full rank. Therefore we can say that 0 is an eigenvalue. Therefore we can say that determinant of this matrix is equal to 0. Determinant of this matrix is equal to 0 implies that 0 is an eigenvalue. 0 is an eigenvalue implies that it is not a positive definite, because a matrix is positive definite if all the eigenvalues are positive. So here we get 0 is an eigenvalue. Therefore when n1 is equal to n2 is equal to etc. to n5 equal to n5, then we can get A is not a positive definite matrix. Therefore our third option is also false. Now for our fourth option, which says that n1 greater than n2 greater than etc. up to n5. So I take him the value for n1 is equal to 5 and n2 is equal to 4, and so on. N5 is equal to 1, and we also know that 5 greater than, 4 greater than, etc. greater than 1. So all the given conditions are satisfied. By using that we can construct the matrix A is equal to 1 by 11, 1 by 10 etc. up to 1 by 7, and 1 by 10, 1 by 9 etc. up to 1 by 6, and etc. up to 1 by 7, 1 by 6 etc. up to 1 by 3. By using Aij is equal to 1 by ni plus nj plus 1. So for the A1 here we get the A11th element. So A11 stands by, that is A11 is equal to 1 by n1 plus n1 plus 1. So n1 is equal to 5. So 5 plus 5 plus 1, which is equal to 11. So we get 1 by 11, and similarly we can get the rest of these elements. And by using the definition of Cauchy symmetry matrix, it is a Cauchy symmetry it is a Cauchy symmetry matrix, and all the entries are positive and are distinct. Therefore we can conclude that A is a positive definite matrix. Therefore our fourth option is also correct. Or otherwise we can check whether all these leading principal minus are positive or not. For this matrix all the leading principal minus are positive. Therefore we can also say that A is a positive definite matrix. So our correct options of this question are option number 1 and option number 2 and option number 4, and our third option is a wrong option. Okay, thank you. If you like my video, please subscribe my channel and also share with your friends.